Hello everyone. Again I come here with more illustrations on triangle trigonometry. Actually speaking, sky is the limit. I mean, how many sessions we can have on triangle trigonometry, God only knows. But I think in this session I should be able to give you the maximum thing what we can expect. I mean, good problems collection I wanted to just present in front of you. Now I start with more illustrations on triangle trigonometry, and my first illustration is P is a point on the circumcircle of cyclic quadrilateral A1, A2, A3, A4, and Dij is the distance of point P from the chord AIAJ. I mean, this is the description given. Obviously, we will have to draw the figure. Then which of the following is not true? And some 4 options are given to us. So, my correct approach, as you know, must be that we should be able to draw the figure. If you draw correct figure, then perhaps you can interpret from the figure itself. But before doing that, one approach says that if I try to take a simpler problem than the given one, and first try to attempt that, and then I try to use similar idea to a bigger problem or more complicated problem, then that is also one way of solving. So what I do is, I take some general case here where triangle ABC is there and AN is a diameter of the circumscribing circle and AM is an altitude of triangle ABC. Now you all must be wondering that why I am doing so. Now when I complete something about this, then you will be able to understand that why did I start with this. That I take a triangle ABC, I draw altitude AM, I draw a circumscribing circle, and I have taken AN as a diameter, and I join N to C, and I realize that triangle AMB and triangle ACN, they are similar. Stretch your mind why I am saying so. It is just 1 or 2 seconds thing. You will be able to understand. Now, using similarity, I can write AM upon AC equal to AB upon AN. And that leads to AM equal to AB into AC upon AN. Now, this is crux of the thing. Now, AM, that is altitude. AB into AC, those are the 2 sides starting from vertex A. And AN is the diameter. So, instead of writing it as AM equal to AB into AC upon AN, I try to write now in wording. I write altitude from A is AB into AC, that means 2 sides starting from vertex A, upon diameter of the circumcircle. This idea I propose to use towards the given problem. Now, I am going to use this, and how do I use it? Look at the beauty of the question. Now, question, if you try to draw figure, will look something like this. That P is a point on the circumscribing circle of quadrilateral A1, A2, A3, A4, and then Dij is the distance from the chord AIAJ of point P. So everything I cannot show here, but you can understand that I will be writing D12 notation for that distance of P from chord A1, A2. Something like that I'm going to do it. So similarly, I can write D34 also. And that would be nothing but altitude of triangle PA3, A4 from the picture. Now, that result what I have written there at the top, I want to use, but before that, I try to write D12 and D34 using that same result. That altitude from A, what I have written there, that result you use here, and that would be giving us that D12 equal to PA1, PA2 upon diameter. I'm not writing the entire statement, diameter of the circumscribing circle, etc. Because all the triangles, whether it is PA1, A2 or PA1, A3 or PA1, A4, any triangle you take, circumscribing circle is same. So diameter will remain throughout the same. So I'm just writing their diameter. I hope everyone understands. Now, I am writing that D34 and that would be PA3, PA4 upon diameter. Now, if I go for the product, I can understand that in the product finally, everywhere you will be getting PA1, PA2, PA3, PA4 type. Before that, I have written expressions for D13 and D24 also. If I go for their product, again there I will be getting PA1, PA2, PA3, PA4. So what I realize is that D12, D34 is the product PA1, PA2, PA3, PA4 upon diameter square, and that also can be written as D13 into D24. Why that? You can also write that as D14 into D23 also. I hope you understand why I'm saying so. So basically we have D12 into D34 equal to D13 into D24 equal to D14 into D23. We are asked the wrong option, which is not true, and that is nothing but option A. And why remaining three options are correct, you can very well verify yourself. Now I move to the next one from here, and that is that ABCD is a cyclic quadrilateral, RA is the inradius of triangle BCD, and RB, RC, RD have similar meanings. And then we have to pick up the correct option. Now when you look at the question, without drawing figure, I don't think you will be able to understand what RA stands for. So let us draw first figure where RA, RB, RC and RD you can actually show in picture. And I do that. And I realize that some two figures you will have to draw and which would look something like this. I have shown that RA, RB, RC, RD. In addition to that, as I have been saying from beginning, please don't feel shy to give names. So I have written some angles also there. I have written alpha, beta, gamma, delta. Mind you please that whatever I am writing as alpha in the first picture, similar notation or same notation I should say, I have written in the second figure also. Can you tell me that why I have written angle ABD alpha and in the second figure why I have written angle ACD as alpha? I hope everyone gets the idea. Now ABCD is a cyclic quadrilateral. So if I draw circle even in the second figure, you will realize that both the angles are on AD. So obviously they will be equal. So if I am using notation alpha in the first figure, then why do I use alpha, same notation in the second figure? This is the reason behind it. Now from here, I have now triangles like ABD, ACD, ABC and also ACD. Now they all have same circumcircle and hence they have same circumradius also. Also, I pick up one by one all the triangles and I will write as like from triangle ABD, I write cos alpha plus cos delta plus cos A. That is sigma cos A kind of thing. Right? And sigma cos A we have formula. That is 1 plus R upon R. So I will write that as 1 plus RC upon R because now here in radius is small rc. Now similarly, I pick up triangle BCD, triangle ABC and also triangle ADC and I write similar three equations. I realize that there is a relation between angle A and angle C, angle B and angle D. And what is that relation? That basically since ABCD is a cyclic quadrilateral, hence angle A and angle C, they have relation. Angle B and angle D, they have relation. What is the relation? That cos C will turn out to be minus cos A and cos D will turn out to be minus cos B. So my plan is that I will add equations. Which equations I will add? I will add equation 1 and 2 so that cos A and cos C terms can be finished. And I will be getting cos alpha plus cos beta plus cos gamma plus cos delta. And it is 2 plus RA plus RC upon capital R. Now similar idea I use for equation 3 and equation 4 also. And when I add, again now cos B and cos D terms will vanish because one is negative of other. And I get cos alpha plus cos beta plus cos gamma plus cos delta equal to 2 plus RB plus RD upon R. Now both the equations 5 and 6, they have on left hand side cos alpha plus cos beta plus cos gamma plus cos delta. So what does that lead to? Does that not tell that RA plus RC should be equal to RB plus RD? So what is the correct option? Correct option is B. Now picture figure if you draw correctly. Also, in addition to the trigonometric formulae, what else I have used? I hope everybody understands that. What other idea I have used in the entire thing other than drawing picture and using formula? Can you stretch your mind? We have used simple logic, simple theorem, what you have learnt in your previous classes. What was that? Angle on the same chord in the same segment would be equal, right? That we have used here. Now that actually has solved the problem. Now I move from here to the next, and the next one is that ABC is an acute triangle. D is a point between B and C. DP is perpendicular to AB and DQ is perpendicular to AC. Then the least value of PQ is required. and capital R is used for circumradius of triangle ABC. Correct option we have to choose, that goes by default. Try to draw the picture. Take some point D on BC, show points P and Q on AB and AC such that DP is perpendicular to AB and DQ is perpendicular to AC as given in the problem. So picture would look something like this. Also AM, which I have shown as altitude, that was not given in the problem, but that I have drawn from my side. I hope everyone can see that. Now what observations you make? I realize that circumcircle of triangle APQ and the circle which circumscribes the quadrilateral AQDP, that would be same. Can everyone see that? I hope you can do that, correct? And from there I move and I use a new notation now. I say circumradius of triangle APQ, I am naming as R1. I cannot use R because R is already kept, reserved for circumradius of triangle ABC. AM altitude, as I said, I have already mentioned to you. Now D is a moving point. Mind you please, I have written this statement deliberately for you to understand that question is regarding the least value of PQ. Now how many of you think that PQ is a varying quantity? If PQ is a varying quantity, then only you can find its minimum. So the statement that D is a moving point and hence DP and DQ are varying quantities and hence PQ is a varying quantity. So first I made sure that we can have minimum or least value of PQ. Also, I realize in triangle APQ, PQ upon sin A is 2R1. I will not write 2R. I hope everyone understands why. And 2R1, according to the picture, is nothing but diameter AD, right? And hence I write PQ equal to AD into sin A. Now AD is bigger than AM or equal to AM also if D moves to position M. So hence I write this is greater or equal to AM into sin A. Fine. Now what is AM? It is altitude and altitude is used in the area. So I try to use that area formula and I write PQ is greater or equal to 2 delta upon BC into sin A. Now BC upon sin A, this has a special meaning. What is that? It is nothing but 2R. So PQ is greater or equal to now 2 delta upon 2R. 2 and 2 gets cancelled and I get PQ greater or equal to delta upon R. Now this is delta is a standard notation. R is given in the problem only. So I think we have arrived at the situation. I am saying PQ is greater or equal to delta upon R means what? The minimum value is nothing but delta upon R. So the correct option is C. Now picture was required. Without picture, question wouldn't have been done. Okay, so let's move to the next one. And it could be perhaps my last question in the session. If P is a point in a square ABCD such that PA is equal to 1, PB is equal to 2 and PC is equal to 3, the area of the square in square units we are asked to find. And 4 options are given. We have to pick up the correct one. Now picture is also given so that there is no ambiguity at all. Now idea of solving what I'll be using here would be altogether different from what you have learned till now. There could be another method also. I do not deny. If you wish, you can go by any other method. But I wanted to introduce that some method which is actually out of the world kind. And that is that you rotate a figure and try to simplify the situation, which I will be using here. What I do here is that I rotate triangle PBC about B by 90 degree in anti-clockwise direction. Why and how I think of something like this? I try to utilize the idea that BC is perpendicular to AB. So the moment you rotate triangle PBC by 90 degree in anti-clockwise direction, BC will fall on BA, right? And P will go to position P dash. I hope everyone understands. And then I realize that since C goes to A, triangle PBC becomes now triangle P dash B C dash according to the figure what I have written. Fine. And also rotation does not change the length and hence PB and P dash B, they will remain same. So they are nothing but 2 and 2. Now from here what you realize that also since PB is rotated by 90 degree, so PB P dash is a right angle, and also since PB and P dash B, they are equal, it is isosceles also. So it is isosceles right angle triangle. Fine. So P dash PB, this angle is 45 degree. Also, what all other things you can see? I can write PP dash also, since it's right angle triangle. Now P dash B is a right triangle, so I can also write PP dash using your Pythagoras theorem. I have got that as 2 root 2. Length P dash A is actually nothing but PC. So it is same as 3. So look at the triangle now, A dash P, PP dash. And you realize that it is going to be now a right triangle because 1, 2 root 2 and 3, they are Pythagorean triplet. And hence I realize that angle APP dash turns out to be 90 degree. Now look at the figure. APP dash is 90 degree. P dash PB is 45 degree. And hence angle APB is going to be 135 degree. I will take now only triangle APB into consideration. I may take AB as X. And I realize that I am free to use now cosine rule. Let me tell you one thing. Cosine rule we use if one angle and 3 sides are involved in the problem. Here 3 sides are involved in triangle APB, I am saying. 3 sides are involved and angle APB, just now we have found it is 135 degree. And from there I go for cos 135 degree. I substitute values also there and I finally get x square as 5 plus 2 root 2. If my AB is x, then what does x square represent? Is it not area? And question was regarding area of the square only. So area of the square is 5 plus 2 root 2 and hence the correct option is nothing but C. I hope this was quite different problem from all others, and here I end my session. Please stay tuned till I come again with something new. Thank you.